Welcome to solverfy.
So in this problem, we are given a sample of the testosterone, which has a molecular formula of C19H28O2 and which contains 3.88 times 10 to the power 21 hydrogen atoms. So in first part of this problem, we have to find out how many atoms of carbon does this sample contains. So if we let that the number of atoms of carbon contained in this sample as X, then we can set up a ratio of carbon and hydrogen atom in the sample and in one molecule of the compound. So if X is the number of carbon present in the sample of testosterone, and we have given the number of hydrogen present in the sample as 3.88 times 10 to the power 21. So we can write X over 3.88 times 10 to the power 21 is equal to the ratio of carbon and hydrogen in one molecule of the testosterone, which is we have 19 carbon and 28 hydrogen. So we can write 19 over 28. So from this ratio comparison, we can easily find the value of X, which is the number of carbon atoms in the sample. So the value of X will be equal to 19 over 28 times 3.88 times 10 to the power 21, and it will give us a value of 2.63 times 10 to the power 21. So this is the number of carbon atoms that is present in the sample. Now, in part B of this question, you have to find out how many molecules of testosterone does it contain. So again, if we consider the number of molecules of testosterone which is contained in the sample as X, then we can compare that with the number of hydrogen atoms present in the sample, which is again 3.88 times 10 to the power 21, and we can compare it with the ratio of the testosterone molecule and hydrogen atom in case of one molecule. So in one molecule of the testosterone, we have one molecule over the number of hydrogen, which is 28. So 1 over 28. And from here, we can find the value of X, which is the number of molecules of testosterone in the sample. So it will be 1 over 28 times 3.88 times 10 to the power 21. And this will give us a value of 1.38 times 10 to the power 20. So this is the number of molecules of testosterone which is present in the sample. Then in third part of this problem, we have to find out how many moles of testosterone does this sample contain. So here we have calculated how many molecules of testosterone is contained in the sample, and now we have to find out the number of moles of the testosterone contained in the sample. So as we know that 1 mole of any substance contain 6.02 times 10 to the power 23 molecules. So from here we can easily find out how many moles this much molecule will contain. So 6.02 times 10 to the power 23 molecules are contained in 1 mole. That means this much molecules, which is 1.38 times 10 to the power 20. So this much molecules are contained in 1.38 times 10 to the power 20 over 6.02 times 10 to the power 23 mole, or 2.30 times 10 to the power minus 4 mole. So this is the number of mole which is contained in the sample. Now, in last part of this problem, you have to find out what is the mass of this sample in grams. So to do that, we have to find out the molar mass of the testosterone, and molar mass means the mass contained in 1 mole. That means from there we can find out what is the mass contained is this much mole, which is the number of moles for the sample. So let's find out the molar mass of the compound we given. So the formula for testosterone is given as C19 H28O2. So we can find out the molar mass just easily adding up the molar mass of each individual atom. So first we have carbon, which has a molar mass of 12.01, and we have 19 carbons, so we'll multiply this by 19. Then we have hydrogen, which has a molar mass of 1.008, and hydrogen has a molar mass. We have 28 hydrogen here, so we'll multiply it by 28. Then we have oxygen, which has a molar mass of 16, and we have 2 oxygen here, so multiply it by 2. It will give us a value of 288.42 gram per mole. So this is the molar mass of this compound. So this much mass is contained in 1 mole. That means how many mass is contained in this much mole? So we write 1 mole of the testosterone contains 288.42 gram. That means 2.3 times 10 to the power minus 4 mole contain this will contain um 2.30 times 10 to the power minus 4 mole times this mass, 288.42 gram per mole, and this will give us a value of 0.066 gram. So this is the mass of the sample. So we are asked in the final part of this question, we are asked to find out the mass of the sample in grams, and this is the mass of the sample in grams.